higher order polynomials, right, as I say, right, okay, that means they go higher than x cubed. So there might be an x to the power of 4, and then there's an x cubed term, an x squared term, an x term, and a number. Or x to the power of 5, 4, 3, 2, 1, a number. Right, okay, right. So as I say, you won't be asked to solve anything higher than an x cubed, right, but you might be given a graph of something higher, okay, right. So if it's an x to the power of 4, x to the power of 4 term, girls, how many solutions is there? 4 solutions, so that means it crosses the x-axis 4 times, right? So it might look something like 1, 2, 3, 4. See that? So there's a solution, there's a solution, there's a solution, and there's a solution. Okay? Is that alright? X to the power of 5 means it's going to cross the x-axis. How many times? 5 times, because there's 5 solutions. So crosses once, crosses twice, crosses 3, crosses 4, crosses 5. Is that okay? Please note, if it's x to the power of an even number, so if the highest power of x is x to the power of an even number, it ends up pointing the same way as it started, as in it started high, it finished high, right? Whereas if it's x to the power of an odd number, it'll end up the opposite. So if it starts low, it finishes high, right? As in, if it was x to the power of 17, that's an odd number, right? Okay, I'm not going to draw on this, okay, but ... it will start low and finish high. How do I know? Because it's an odd number, right? Okay, if it was x to the power of 16, and it starts low, right? Okay, it's going to finish low. Okay, so if it's an even number, it'll start and finish in the same direction. Does that make sense to you? Right, okay. So if it's an odd number, it finishes in the opposite direction, and if it's an even number, it finishes in the same direction it came from. Does that make sense? Right. Yeah. Is that okay? Right. And again, right, what else do I need to tell you? Right, if it was, just be careful with this. If it was x to the power of 4, so it's an x to the power of 4, right, so we'll say that means it crosses 4 times, 3, 4, okay, so crosses 4 times. Just be careful with, it might look like this. So it might cross, and cross, and cross. So it just touches there, right? Okay, so if I just said this was 2, this was 1, this was minus 1. The factors would be x equals minus 1, x equals 2, and remember, because it touches, x equals 1, x equals 2, what have I to do with the 2? Write it down twice, okay, because there's equal roots there. Okay, so remember, x to the power of 4, you need 4 solutions. X to the power of 5, you need 5 solutions, etc. Is that alright? Okay, that's all you need to know about higher order polynomials. Right, if it's even, they start and finish in the same direction. If it's odd, they start and finish in the opposite directions. And there's 5 solutions, so that means it crosses the x-axis 5 times. There's 4 solutions, it crosses 4 times. Right, and just watch the equal roots. So if it touches off it, if it hits the x-axis and turns back at the x-axis, right, you have to write that root down twice, because that means there's equal roots. Are we good with that? Right, the last thing I want to talk about is, I should have talked about this when we were doing cubic equations, right? Okay, so I'm just back to cubic equations, right, of cubic functions. Right, okay. Now I'm going to doodle for a minute, okay. Remember when we had a smiley face, right, we had a minimum point, didn't we? Right, and when we had a sad face, we had a maximum point. Would you agree? What? Can I what? Move it down, sorry. Okay, right, so we had a maximum and a minimum when we were doing quadratics, okay, right? Okay, because a cubic equation, right, okay, and you can write this bit down, This, I'm not doodling anymore, right? Okay, because a cubic equation, it doesn't have any minimum because it goes on forever that way. And it doesn't have a maximum, sure doesn't it goes forever that way. What we do is we call these turning points. Turning points are where they turn and go the opposite direction. So it was going up, turns, goes down. Was coming down, turns, it goes up. These are called turning points, right? Okay, and we call the one at the top, we call it the local max. So it's not the max of the curve, because the curve goes on forever that way, right? We call it the local max. And guess what we call this one? The local min. Okay? Right, that's all I have to say about this chapter.